So in today's lecture, we are going to discuss the Young double slit experiment, right? Young double slit experiment, double slit experiment. What is Young double slit experiment YDSE? Right, it was performed in year 1801, right? In the Young double slit experiment, the scientist took the two slits, right? Suppose this is the cardboard and he made the two slits, right? These are the two slits, right? It is the cardboard, the two slits are made and a source of light is placed in between them, and the separation between these two slits is assumed to be small d, and from here, right, another screen at separation capital D, right? This is the slit S1, this is the slit S2, this is the rectangular slits, right? And this is the screen is placed at separation D from these two slits, right? So what they found on the slits, what they have found, when a source of light is placed, right, just in between of these, right? Suppose this is the source S is placed, all right, and the separation between them is D. So if the source of light is placed over here, and the very beautiful the fringe pattern is obtained, right, in the mid a constructive interference or the bright fringe is found, and right, a bright fringe is found, and consecutive the dark fringe is found, right? After this, on the other side is also the dark fringe is found, right? Then a bright fringe is found, then a dark fringe is found, like this, all right? This is the bright, then again the dark fringe, the bright, right, this is the bright, and this is the bright, this is the dark fringe is found, all right, like this. So on the screen they found this type of the fringe pattern, right, like this. The rectangular consecutive bright and dark fringe are obtained if the source, from the source S the light is obtained, right? These light incident on the slits, and after that these two slits act as a new source of light, right, and which are vibrating in same phase, right? And the secondary wavelet, they act as a secondary wavelet and source, they produce the light, right, the wavefront, and interference, due to interference the consecutive bright and dark fringe are obtained on the screen placed at separation capital D. This is the 3D view, all right. But if you cut, right, like this, if you cut the cross section, if you take the cross section of this, right, I'm giving you an example. This is the cardboard, and in the cardboard the two slits, one slits and another slits is formed, and you put the source and another screen is placed. So on this screen, this type of the fringe pattern here you obtain. These are the two slits, one slit, two slits, and this is the source, right? So this fringe pattern is obtained here, all right. So if you make the cross section view like this, these are the two slits, fine. This is the source symmetrically placed, and this slit is S1, this slit is S2. At the separation D, capital D, the screen is placed, so when if it acts as a point source, so when a wavefront is reached, right, when a wavefront is reached over here, so you tell this is the spherical wavefront, suppose, all right. So when the wavefront, first wavefront, first, second, when the wavefronts are originating from the source, so they are reaching continuously to this point, so you tell me the source S1 and S2 act as a new source of light or not? according to the Huygens principle, these source act as the new source of light, and from here the new source, they act as a new source of light or secondary wavelet, and the again the spherical wave fronts are produced, and when they propagate in the medium, right, so on the screen they get the bright and the dark fringe like this. This is the central bright fringe, you can say, which is at center, and consecutive bright and dark fringe you get on the either side. Is it clear or not, you tell? Like this, like this, right? This is the bright and the dark fringe, consecutive bright and dark fringe you get. Is it clear or not, you tell? So this is what? This is called the YDSE experiment performed, right? And the making of this consecutive bright and dark fringe can be explained on the basis of the wave theory of the light, right? We will assume that light is wave, not a particle, otherwise it cannot be, the making of the fringes cannot be explained if you assume this is the particle, right? This is called the central bright fringe, right? This fringe is called the central bright fringe, CBF. All right. This is called the first bright fringe. This is called the B1, right? This is called B2. Are you getting or not? Right. And this is called the D1. This is called the second dark fringe. This is called the third dark fringe. Is it clear or not, you tell? Yes. So right. So this is the cross section view. This is the screen. All right. Copy this. So now we will try to find the position of the bright fringes, right? Position of constructive interference, positive positions of bright fringes, or you can say we will apply the condition for constructive interference, right? Interference. First of all, I want to say S1 and S2 are in same phase, right? They are coherent source. S1 and S2 are coherent sources. Why they are coherent sources, please tell? Because they are present on the same wavefront, and these new source of light act as a secondary wavelet which are vibrating in the same phase. So from a single source we have produced the two coherent sources, S1 and S2. When the two coherent sources produce the wavefront in the forward direction, due to the interference at different position, different intensity of the light we are getting. Here the intensity is maximum, intensity is maximum at the B1, B2 and CBF, right? This is the intensity. This is also called the B1, this is also called the B2. This is dark 1, here the intensity is minimum, this is dark 2. On the either side the consecutive bright dark fringes are obtained. So where the bright fringes are obtained on the screen like this is the bright fringes. So the position of the bright fringes we are going to find. Here we will apply the condition for constructive interference, right? So how to do that? Listen, suppose these are the two sources of light, S1 and S2. Fine, this is S1 and S2. And now if you consider a point P, from this is the center of the screen, center, and this distance is supposed to be y. So from here the one wave is reaching, from here the another wave is reaching. Are you getting or not? So this is the distance traveled by the first wave, right? This is the distance traveled by the first wave, and this is the distance traveled by the second wave. So this is the first wave, this is the second wave. So is there path difference between the two waves? Yes. So what is the path difference? Right, at point P, the path difference between, right, two waves. Yes, what is the path difference? say S2P minus S1P. S2P is the path traveled by the wave 2, S1P is the path traveled by the wave 1. So what is their difference? S2P minus S1P. Look, although this angle or the position is at very small distance at millimeter, right? This distance is approximately 1 meter. So listen one thing, if you take, assume this is the center and if you take the circle, right? So these two distances are same. So this is the extra distance. This is the path difference. You make the perpendicular over here, suppose, right? So this is the distance, this P dash, you may assume. So what is this? This is the path difference. You understand or not? Because S1P and PP dash both are equal. So this is the extra path. It means delta X is equal to S2P minus S1P is equal to what? Listen, if you assume this angle is to be theta and the small d, what is small d? Small d is the distance between two slits. What is small distance between slits, right? What is capital D? Distance between screen, distance between slits, distance between slits, and this is the screen, right? So if you have, this is, suppose this is the perpendicular. So what is the sine theta here you will apply? Sine theta is nothing but perpendicular S2P dash upon hypotenuse S1 S2 delta X upon D. So if you multiply by D, sine theta is equal to delta X. So what is the delta X? Delta X is nothing but equal to D sine theta. Is it clear or not, you tell?
Yes.
So this is the path difference between the two waves reaching at the point P. All right. Listen, one more thing. If you take, this is the one line, right? This is the another point like this. Look, if this angle is theta, right? This angle is theta, and this is the 90 degree approximately, right? So what is this angle? Please tell. Right. I'm making here a little big figure, right? Like this. This is the S1, S2. This is the point P. So make the perpendicular over here. If this angle is theta, also from the center of the two slits, join this line. If this angle is theta, this is approximately 90 degree. So it is what? Say 90 minus theta.
Yes.
This angle is 90 minus theta or not? So what is this angle? Please tell. Theta. It is 90 minus theta. So therefore it is theta, right? If you assume this is to be Y, getting, and this is to be capital D, right? So tan theta is what? I'm writing here. And if this angle is theta, this is Y, this is capital D. Tan theta is what? Tan theta is nothing but Y upon D, right? But if theta is small, so sine theta approximately equal to tan theta is equal to theta, right? So tan theta, yes, what is the tan theta? Tan theta is nothing but sine theta. From here, what is the sine theta? Sine theta is nothing but equal to, wait for 1 minute, Y is equal to D. Sine theta is equal to delta X is equal to D sine theta, tan theta, Y is equal to D tan theta, right? And what is the D? D is equal to sine theta. And what is the sine theta? Say delta X upon D. Is it clear or not, you tell? Right. So from here, the path difference is equal to YD upon capital D, right? Copy this. So this is the path difference in the form of YD upon D. Is it clear or not, you tell?
Yes.
Now what is the condition for the constructive interference? Tell me. The path difference, yesterday I told you, what is the condition for?
Cos 1.
Yes. Condition for bright fringes. Bright fringes. The path difference between the two waves should be equal to what?
2 and 5.
Yeah, 2 and pi is the phase difference, and the path difference must be equal to n lambda. So what is the path difference? So path difference is equal to d sine theta is equal to what? Say n lambda. Is it clear or not? And
Yes, sir.
in place of sine theta, you can put the tan theta is equal to n lambda, and tan theta is equal to what? Tan theta is equal to y n upon d, right? N lambda. Y upon d. Y is what? N d lambda over d. This is nothing but what is y? Yn. This is the distance of the nth bright fringe. What is this? This is the distance of nth bright fringe from center, or central bright fringe, you can say. Is it clear or not, you tell?
Yes, sir.
For example, listen one thing. If you put after this, you may write over here n is equal to 0. If delta x is equal to n lambda, what the n value we will put? 0, 1, 2, 3, right? That. So if you put the n is equal to 0, what is y 0?
C.
Yes, y is nothing but z0. So this is the position of CBF. Yes, central bright fringe, CBF. Fine.
Yes, sir.
If you put n is equal to 1, then y1 is equal to what? D lambda over d. Are you getting or not? This is the position from the center. The central bright fringe is over here. And if you consider this is the bright fringe B1, so this is the y1. What is the value of y1, you tell? Say d lambda over d.
Upon square. Yes,
Right. For n is equal to 2, y2. This is the position of first bright fringe. Right?
Yes, sir.
Very good. And 2d lambda over d.
Yes.
This is what? Position of
Second bright fringe.
from
Center.
center. So if you consider this the B2, this is equal to y2 is equal to 2d lambda d, and so on, right? And so
Yes.
on. For the nth bright fringe, n d lambda over d. Is it clear or not, you tell?
Yes,
Copy this. So now we will discuss the condition for, right?
yes, sir.
Condition for dark fringe, right? Position, or you may write after this position or position of dark fringes, and position of dark fringes. So to find the position of the dark fringes, that is the distance from center of D1, of D2, of D3, we are going to find. So for the dark fringes or the destructive interference, destructive interference, what is the condition? Please tell.
Delta
The
x is equal to 2n minus 1 upon
lambda by 2. And what is the delta x we have found? This is the delta x.
Yes.
So it is equal to what? Say d sine theta. 2n minus 1 lambda by 2, and n would be 1, 2, 3, and so on. And sine theta is approximately tan theta, right? And tan theta is nothing but equal to y by d. Tan theta is y by d. So it is 2n minus 1 lambda by 2. So y is equal to 2n minus 1 d lambda over 2d. Fine. D lambda over 2d. And this is the what? This is the position of nth dark fringe, right, from center. Fine. So listen one thing. So how to find the position? Again, we will put n is equal to 1, 2, 3. Are you getting? If you put n is equal to 1, n is equal to 1 mean from center, what is the distance?
First down.
Yes, 2 into 1 minus 1 d lambda over 2d is equal to what? 2 minus 1 d lambda over 2d. For n is equal to 2, the position of second direct fringe from the center, 2 into 2 minus 1 d lambda over 2, it is equal to what? 2 to the 4 minus 1, 3. 3 d lambda over d, right? 2, 3 d lambda over 2d, n is equal to 3. It is 5 d lambda over 2d. Are you getting or not?
Yes.
And so on, right? For the nth bright fringe, 2n minus 1 d lambda over 2d. So listen one thing. If you assume it is to be d1, right? So this distance is what? This distance d1. The d1 distance is d lambda over 2d. From center, this is the distance. For d2, what is the distance? 3d lambda over 2d. What is the distance? 5d lambda over 2d. Is it clear or not? You tell. Copy this. So let us once again discuss this thing. Suppose these are the two sources of light, S1 and S2, which are coherent source, and this is the screen placed at distance d, right? This is the bright fringe you assume, then this is the dark fringe, this is the bright fringe, this is the dark fringe again. So on the either side, the consecutive bright and dark fringes are obtained. This is dark fringe, this is the bright fringe, this is again dark fringe, bright fringe. This is the central bright fringe? Fine. This is the CBF. Are you getting or not? If you consider this the D1, what is this distance? Say, this is d lambda over 2d. And if this is the d2, what is this distance?
3d by lambda upon
2d, right? Upon 2d. And if you consider this the third dark fringe, this is the d3. So what is this distance? 5d lambda over 2d, right? This is the central bright fringe present over here. Suppose this is the b1. What is the distance? Say d lambda over d, if you remember. D lambda over d. If you consider this is the b2, so what is the distance?
2d lambda upon d.
D, right? And if you consider this is the b3, so what is this distance?
4d
Say,
lambda.
yeah, this is 3d lambda over d, right? 3d lambda over d. Are you getting or not?
Yes.
So in the same way, here you may write this distance is what? For if you assume this is d1, what is the distance? Below the central bright fringe, this is d lambda over 2d, right? From here, if you consider this is 3d lambda over 2d, and so on. If this is the b1, right? For the b1, what is this distance? Say d lambda over d. If it is b2, the distance is what? Say 2d lambda over d, and so on. Are you getting or not?
Yes.
Right? So listen one more thing. If you consider this is the source S1 and S2 and the source S is placed over here, we will define now the fringe width. Fringe width, right? Fringe width. What is the fringe width? Fringe width is represented by beta. The width of this fringes is called the fringe width, which is nothing but the distance between two consecutive, right? Either bright fringes or dark fringes. Is it clear or not, you tell?
Yes.
For example, if you consider this the d lambda b1 and b2, so if it is d lambda over d, this is 2d lambda over d. So what is the distance between two consecutive bright fringe? Please tell me. That is distance between two consecutive bright fringes. Can you tell? Bright fringes.
Yes, so it will be the 2 d lambda by d minus d lambda by d.
So 2d 2 minus 1 is equal to 1d lambda. Or you can take this b3 minus b2 or y2
Yes,
minus 3d lambda over d minus. Right. Either you may take 2d lambda over d minus d lambda over d. So what is the answer? Say d lambda over d. Or you can subtract 3d lambda over d minus 2d
2
lambda
d
over d.
lambda over
So
d,
this is again d
d
lambda over d.
lambda over d.
So the fringe width, the beta, is nothing but d lambda over d. Is it clear or not?
Yes,
Or you may find the uh, fringe width with the help of the dark fringe. If you subtract this distance minus this distance, or that is distance between consecutive dark fringes, tell me what is that? It is 3d lambda over 2d minus
2d
d lambda over 2d. So it comes again d lambda over d. Even 5d lambda over d, 5d
yes,
lambda over 2d minus 3d lambda over 2d. What will you get? The d lambda
2
over d. Yes. 5 minus 3, 2, and 2 divided by 2 is equal to d lambda. So
d lambda.
either you find the fringe width with the help of the bright fringes or dark fringes. The fringe width, right, you will get always equal to d lambda over d. Is it clear or not?
Yes,
Right. Although we have the formula, right, for bright fringes, what is n? What is yn? N d lambda over d.
yes,
And what is the n plus 1? Next fringe, next distance, the distance of the next bright fringe, n plus 1
yes,
d lambda
d
over d.
lambda over d.
So beta is defined as yn plus 1 minus yn is equal to n plus 1 d lambda over d minus n d lambda over d. So n plus 1 minus n, if you take the d lambda over d common, so this is d lambda over d. So this is the beta. Is it clear or not, you tell?
Yes, sir.
Right. So this beta depends upon fringe width. Therefore, fringe width depends upon, tell me, depends upon. First, beta is proportional to the d. D is the distance between the slits and the screen. Second, it is also directly proportional to lambda and inversely proportional to small d. Small d is the distance between the two slits, right? Copy this. So this is the fringe width, which is represented by beta, depends upon d, capital D. If you increase the capital D, the beta will increase. If you increase the wavelength, beta will also increase. But if you increase the d, the fringe width will decrease.
Decrease.
This is the definition of the fringe width. Linear fringe width, you can also say. The fringe width is nothing but the width of the this portion, width of the this portion. So you will see the important point is that all fringes are of same the width, right? You will say the width of all fringes are same, right?
Yes,
Width of the all fringes are same. This is the one point. Now the angular fringe width, angular fringe width, right? Angular fringe width, it is represented by sometime theta, right? Angular fringe width. What is the angular fringe width? Listen one thing. If you consider these are the two slits, right? This is the screen. This is the S1 and this is S2, right? Fringe pattern is obtained over here. So if you consider this is the central bright fringe, here this is the D1, then B1, then right D2, this is D1, this is D2, right? On this side also There will be what? So d1. Are you getting?
Yes.
So what is the angular fringe width? The angular fringe width, right? Sometimes it is represented by omega, right? So angular fringe width is nothing but the angle subtended by the central bright fringe. Angle subtended by the central bright fringe on this slits, right? This is the theta. Suppose I am represented theta. So what is the fringe width? Say it is beta. Are you getting or not?
Yes.
Beta is what? Say d lambda over d. And this is the what? Distance d. Right. What is the angular fringe width? I am writing the definition: angle made by CBF on the slits
Yes.
is called angular fringe width, theta.
Yes.
So how to find the angular fringe width? This angular theta is equal to what? Beta upon d. Right? Beta. What is beta? Say d lambda over d upon d. So dd will cancel out lambda upon d. So this angular fringe width is nothing but lambda by d. So it depends upon what? You tell. Angular fringe width depends upon the lambda, directly proportional to and inversely proportional to the small d. Small d is nothing but distance between two slits. All right. Copy this. So read this question. In this question, the laser light of the wavelength 630 nanometer is incident in the pair of two slits. Right. This is the slit S1, S2. Here this is the source. Its wavelength is what? Say lambda 1. In which fringes are separated. That is the d, small d is given. They are separated by 8.1 millimeter. Now the second laser light produces an interference pattern in which fringes are separated by oh, wait for 1 minute. Slit produced an interference pattern. Interference pattern is over there on the screen, and these are the fringes, right?
Yes.
And now the separation between the fringes is given by 8.1 millimeter. That it is given as the beta. You understand or not?
Yes.
Now if we use the lambda 1 is 630 and lambda 2 is what? Okay, lambda 2 find, right? And the here this is the beta 1, and for the second laser light the beta 2 is what? 7.2 millimeter. Although the system, right, the experiment setup remains same, that is capital D and the small d remains same, right? Only by changing the wavelength. What is the beta? Beta is nothing but d lambda over d. Small d and capital D remains constant. Only if the wavelength is decreasing, if the wavelength is changing, the beta will change. Is it clear or not? From here, capital D and small d are constant and beta is proportional to lambda. So beta 2 upon beta 1 is equal to lambda 2 upon lambda 1. What is okay? And beta 2 is what? The beta 2 is 7.2 millimeter. What is beta 1? 8.1 millimeter. Lambda 2 upon 630 nanometer. Millimeter will cancel out. So lambda 2 is equal to what? 0.72 upon 81 into 630. Right? No 72, 9 9 ja 81. No 7 63. 560 nanometer is the wavelength of the secondary laser light. Is it clear or not? Copy this, copy this. So read this question. In this question, a double slit is illuminated by wavelength, light of the wavelength 6000 angstrom. Right. The slits are what the light is incident over here. This is the lambda 6000 angstrom. The slit S1 and S2, the small d is given 0.1 centimeter, and the distance between the screen and the slits is 1 meter. Is it fine or not, you tell? So here CBF, right? Then B1, B2, B3, and so on, the B10, right? So they are asking what is the angular in the first part, angular position of 10th maxima in radian, right? So you tell me, if this is the beta 10, can you tell me what is the distance? This is what? Say d lambda over d.
Yes.
This is what? B2. For B2, it is this distance is what? 2d lambda over d or not?
Yes.
Right. So for the beta 1, it is beta. The beta is nothing but d lambda over d. For beta 2, it is what? Say 2 beta.
2 beta.
For beta 3, it is what?
3 beta.
For B10 is equal to what? 10 beta.
Yes.
And what is this distance? Say 10. So in this triangle, what is the tan theta? Please tell. Tan theta is nothing but perpendicular upon capital D. So what is the beta? Say d lambda over d upon capital D. It will cancel out. So if the theta is very small, you can think tan lambda over d. What is lambda? Say 6000 angstrom. Is it fine? What is small d? It is 0.1 centimeter. Getting or not?
Yes.
So how much it is? 6 into 10 ki power minus 6 plus 4, 0.06. All right.
Yes.
Wait for 1 minute. 6000 angstrom minus 10. This is minus 6. And it is 0.1 centimeter. 0.1 centimeter is 10 raised to minus 2. So it is 6 into 10 ki power minus 6 in numerator. When it goes, plus 3. So it is 6 into 10 ki power minus 3.
Minus.
Right. And the theta is small. So theta is what? 6 into 10 ki power minus 3 radian is the correct answer. Fine.
Yes.
And the second part, what they are asking, can you read?
Yes. Then separation between minima.
Two adjacent minima. Suppose this is the D1, this is the D2. What is the separation between them? Say beta.
Beta.
Right. So separation between two adjacent minima. Adjacent minima is equal to what? Beta is equal to d lambda over d. Getting or not?
Yes.
So you can put the value d lambda over d. D is what? Say 1. Lambda is 6000 angstrom. Small d is 0.2. It is what? 0.1. 0.1 centimeter. Then it becomes in meter. This is 6 into 10 ki power minus 4 meter. Right. So the beta is nothing but 0.6 millimeter. So the width, right, fringe width is very small in millimeter. Also practically it is found in millimeter. Right. Copy this.
Yes.
So read this question. In this question, in double slit experiment, the fringes are formed at 1 meter from the YDSE separation, and the separation D between the two slits is 0.12 millimeter. Fine.
Yes.
So what is first part? The distance of third arc fringe. This is the CBF. Then this is D1, D2, D3. Would you remember what is this?
Yes, sir.
This
It is d upon d lambda by 2d.
d lambda upon 2d. So can you write it as the beta by 2 or not?
Yes, sir.
And what is d2? Suppose this is d1, this is beta by 2. What is d2? You will say 3 beta by 2.
By 2.
What is d3? 5 beta by 2. Or by the formula, the position of nth dark fringe from center is 2n minus 1 d lambda over 2d. Right? If you put n is equal to 3, so the position of third dark fringe, 2, 3 just 6 minus 1, 5d lambda over 2d, or simply it may write 5 beta by 2. Is it clear or not, you tell?
Yes.
Right. So is equal to 5 by 2 d lambda over d, 5 upon 2 it is, d is 1, wavelength 6000 angstrom it is given. Fine. And the small d is nothing but 0.12 into 10 to the power minus 3. Right?
Yes.
So now when you will calculate, right, you will get 1.25 centimeter from the CBF. Is it clear or not, you tell?
Yes.
In the same way, what is the second part, please tell? In the second part, the distance of third bright fringe from the center. Suppose this is the D1, this is the CBF, this is B1, B2 and then B3.
Yes.
So what is the B3 distance?
3 beta.
3 beta. Right. So Y3 is equal to 3 beta, you will say 3d lambda over d. So 3 into 1, lambda is 6000 angstrom and the d is 0.12 millimeter. 0.12 millimeter. So when you will calculate, it comes to be 1.5 centimeter. This is the Y3, right? After D3, the Y3 comes. So this is the distance comes to be 1.25 centimeter. Then this is the distance of B3 comes to be 1.5 centimeter. Is it clear or not?
Yes.
Copy this. So read this question. In this question, in YDSE experiment, two slits are illuminated, S1 and S2. Right, the light is incident upon this, illuminated by the wavelength. It is 5890 angstrom, and the distance between the fringes obtained on the screen is the distance between the fringes. Okay, the distance between the fringes mean, please tell. They are telling the beta, right? Beta is what? Say it is 0.2 degree. The distance mean the angular, it should be the angular separation, right? The distance between the fringes obtained on the screen is 0.2. So this is not the beta, rather the angular separation, angular width. Then find the whole apparatus is immersed in the water. Actually, it is the distance between the fringes obtained on the screen is 0.2 degree mean. They have given the angular separation, right? Initially, it is what? Say 2 degree, right? The the angular separation they have given, right? Because the beta comes to be in meter or centimeter. So the angular separation between the or the angular width of the fringe is given, right?
Yes.
So what is the angular width? If you remember, beta
D
upon d.
lambda by d.
Yes, d lambda over d upon d. So theta is what? Lambda upon d. Is it clear or not? So theta
Yes.
1 is equal to lambda 1 upon d. The small d does not change. But if all the setup is immersed in the liquid, its wavelength is changed. Is it clear or not, you tell? So the
Yes.
wavelength in the refractive index of the water is what? Say 4 by 3. So in the medium, some medium, the wavelength of the light is changed. The frequency remains same.
Same.
The wavelength become lambda 1 upon mu. Is it clear or not? Here the mu is nothing but the mu of water. Are you getting? So theta 2 upon theta 1 is equal to lambda 2 upon lambda 1. So theta 2 is what? Theta 1 into lambda 2 upon lambda 1. It is 0.2 degree. It is 0.2 degree. Lambda 2 is what? Lambda 1 upon mu water divided by lambda 1. Fine.
Yes.
So it is 0.2 upon mu water, 0.2 upon 4 by 3. It is equal to 0.3 upon t, 0.3 upon 2, it is 0.12 degree. Is it clear or not? Copy this. So read this question. In this question, the path difference between the two waves. Suppose these are the two waves, right? This is the S1 and S2. The one wave is reaching, the another wave is reaching. So what is the path difference at this point? The delta x is 171 5 times the wavelength. If the path difference is this much, this is how much? 0.01029 centimeter. 171.5 lambda. Is it fine or not, you tell?
Yes.
Right? So what the wavelength they are asking? The wavelength is what? It may be written as 1.01029 into 10 ki power minus 7, right? It is equal to 175. Lambda is equal to 1029 upon 171.5 into 10 ki power minus 7. Is it clear or not, you tell?
Yes.
Right. So when you will, right, this is 1029 upon 171.5 multiply by 1000 minus 3 into 10 ki power minus 7, multiply by 1000 and minus 3. So it becomes 10 to the power minus 3 minus 10, minus 3 and minus 7 become minus 10. And when you will calculate, it comes to be 6000. So the wavelength of this light is nothing but 6000 angstrom. Is it clear or not? You can simplify this, you will get 6000, right? Copy this. So read this question. In this question, in the young double slit experiment, the distance between two sources, the distance between sources S1 and S2, D is given 0.1 upon pi millimeter. Fine. The distance of the screen from the source. This is the screen and this is the source. It is what? 25 centimeter. Right?
Yes.
Very good. Wavelength. What the wavelength we are using?
5,000.
Angstrom. Right. What is the angular position? Suppose this is the CBF, then D1, then B1, then D2. So what they are asking? The angular position of D1. What is this? What is this distance, you tell? Say beta by 2. And this is what? D. So what is the tan theta which is equal to theta? Tan theta is nothing but beta upon 2 upon D. So it is 2D into beta. What is the value of beta? D lambda over D. So the theta is nothing but lambda upon 2D. All right. So lambda value is what? 5000. The distance is what? 0.1 upon pi millimeter. It is converted into meter. Fine.
Yes.
So this answer come in radian. So this is 2.5 pi, right? Simplify, in the numerator it is minus 7 plus 4. So it is 2.5 pi into 10 to the power minus 3 radian. Is it clear or not?
Yes.
If you want to convert into degree, so what will you do? For the degree, 180 upon pi, multiply by 180 upon pi, then you will get the answer in degree. Right. So pi will cancel out. When you will calculate, you will get 0.45 degree. So this is the angular position, right? You may write this is the alpha, right? You may write it is the alpha because you may confuse with the fringe width, right? That is the thing. So alpha. So this is the angular position of D1 from center, right? Copy this.